Good day, everybody. Andrew De Silva here again, and today we'll be taking a look at blood clotting. Scientific term for that is hemostasis. Heme, anytime you hear the word heme, we're thinking blood, hemoglobin, red blood cells, and stasis means to stop. Okay, so blood clotting, scientific term, hemostasis. Today we'll be looking at specific learning outcome 3.10, which asks us to explain the process and importance of blood clotting. All right, now our skin is very important. Not only is it important in homeostasis, in thermoregulation, where it allows us to cool down when we're too hot, or to keep our body from losing too much heat when it's too cold via the process of vasodilation or vasoconstriction. But it's also important in that it's a barrier, it forms a barrier to pathogens, bacteria, viruses, fungi, worms. These things, if they enter our body, may cause disease. So our skin is a barrier against them. And our skin also serves as keeping whatever is inside our body, keeping the contents of our body inside where they belong. So that when the skin is broken, it poses a great danger to our health. Now, capillaries are found all over our body rather. They're closely associated to every single cell in our body. So inadvertently, whenever the skin gets broken or damaged, inadvertently blood vessels, capillaries gets damaged. All right. So that we could also have a loss of blood when that occurs. So blood clotting or hemostasis is very important, and it needs to happen quickly to prevent all these adverse effects from happening. Right? So let's just take a quick look at the diagram that we have here. We have a few things in the diagram. Here we have the skin. Here we have the gap, or the cut in the skin, the break in the barrier, which we have put in there the plug already. All right. The plug, the clot. Here we have a capillary associated with that skin cell, that part of the skin. We have prothrombin. Now, prothrombin is a clotting factor. There are a myriad of clotting factors involved in hemostasis. We're only going to look at a few here today. We look at those that we are required to know by the CXC syllabus. So we're preparing ourselves for that examination. As I said, there are a lot of factors involved. We're only going to deal with a few. And even within these factors, there's a cascade of reactions or steps. And we're only going to look at a few of them. All right. We have red blood cells here. We have fibrinogen, which is also another factor involved in blood clotting. We have WBC. So RBC is the shorthand of writing red blood cells, and WBC is the shorthand of writing white blood cells. Right? We all know why white blood cells need to be involved in this process, because it's possible for pathogens, viruses, bacteria, protists, and these things to enter when the skin is cut. And so they need to be there to deal with that eventuality. Right, and finally we have platelets, which is another factor involved in blood clotting. So as I said, there are many different steps, but we're going to condense it down into these few steps so that we can understand it based on what CXC requires us to learn. All right, so step one, the cut occurs, our skin gets damaged. And when that happens, the first thing that occurs is that platelets would start to clump together or coagulate. They coagulate, as you see the platelets here in the blue, they coagulate because they are now being exposed to a chemical called collagen. Collagen is found in our skin, so it keeps our skin springy and nice and young, so that when we get older, some persons would opt to have collagen injections in order to stay fresh and young. But when the skin is broken, the capillary is broken, platelets now get exposed to the chemical collagen, and they form a temporary plug at the damaged site. This plug is temporary, it's not very strong, it would not hold up to any amount of vigorous pressure, so that it needs to be reinforced. So what happens after that is that the damaged cells and the platelets would release a chemical called thromboplastin. Now, thromboplastin is a precursor that will cause thrombin in the blood, as indicated here, to be converted to, prothrombin, which is indicated here, to be converted to thrombin. This process requires calcium salt. I've indicated that with the calcium ion Ca2+. All right. Thrombin would then cause fibrinogen, these squiggly things, to be converted to fibrin, which is more jelly-like and fibrous and longer chains. So they'll bond together. These fibrinogen will bond together to form fibrin, and this fibrin will cause a mesh, further reinforcing the platelets plug and trapping everything else in there, which would include red blood cells and other things which would reinforce that clot. And that is, in a nutshell, a condensed version of the clotting process. And this is what we need to know for the CXC, Human and Social Biology examination. Now, you may notice and you may ask, but Mr. De Silva, why is this process so complicated? Seeing that we need to stop up this hole very quickly, we need to prevent blood loss very quickly, we don't want to die of exsanguination or hypovolemic shock, and we don't want any disease particles, pathogens, cells to enter our body. Why this long drawn out process of clotting? And the answer to this is simple. We do not want clotting to happen by accident. Remembering that the process that I've just outlined is a very small part of the larger picture. There's even greater more processes involved. We want to create all these different steps to create safeguards against clotting happening by accident. We only want blood to clot in these specific conditions, and that is when the blood capillaries are broken and the skin is broken. That's the only time we want blood clotting to happen. We don't want it to happen by accident. Because if blood were clot inside the cells, we would block off the cell and blood wouldn't be able to flow through the cell. So if that happens in our brain, we'll get a stroke. If that happens in our heart, we get heart attack. If that happens in our lungs or any other part of our body, we'll have embolisms, right? And other diseases. So we don't want clotting to happen by accident. So it's important that we have these long drawn out convoluted steps to act as safeguards against clotting happening by mistake. Right? And the opposite is true. We want the blood to clot. We don't want us to have any issues with blood clotting. The disease that occurs when we have issues with blood clotting is called hemophilia. That's when our blood is unable to clot. It's a disease that is passed on through our genes. It's a hereditary disease, and it is where we have issues with certain clotting factors. So the genes don't code for the clotting factors as good as well, so that these clotting factors are absent or damaged, and that causes a breakdown in the whole process. So persons with hemophilia would range from taking very, very long for your blood to clot, or to not being able to clot at all, and they would die of, as I said, hypovolemic shock or even exsanguination. Hemophilia was prevalent rather in the royal family back in the day. We know the royal family back in the day would marry within their own family, and hemophilia being a hereditary disease, that disease would be passed on to their children. So that stayed in their family. Right? So this, in a nutshell, is blood clotting. So now we're going to look at a little synopsis of blood clotting, and then we're going to look at some questions. Right?